Hello everyone, welcome to this video. In this one, we're going to work on Lab 09C, Implement Azure Kubernetes Service, and this lab is from Microsoft Learning GitHub series of videos for SG 104, and I'm going to give you the link as always. So in this one, we have several tasks. First of all, registering the Microsoft Kubernetes and Microsoft Kubernetes configuration resource providers. So we have done similar things, and I'll show you how to do that from portal and also from a CLI environment if you want to. Then we'll deploy Azure Kubernetes Service Cluster using the portal, and then we'll deploy pods into the Kubernetes Service Cluster, and finally we'll look at scale containerized workloads in Azure Kubernetes Service Cluster. It will take about 40 minutes. So first of all, they are doing it. The first task using the Cloud Shell, we're going to register a couple of services or providers. In your task 2, we're going to deploy the resource group, and then inside the resource group, this is the Kubernetes cluster. Then within the cluster, we're going to deploy the Nginx pod, and we'll scale the pod. And then we'll see how to use the public IP address, route table, NSG, Azure Kubernetes Services VNet, node skill sets, and the load balancer. Okay, so let's just get started. So over here, just go to Azure portal and open up the Cloud Shell, and the Cloud Shell, you can just click on that and your Cloud Shell will open. Make sure that you are in the PowerShell window. Okay, in that one, I am just going to copy this command from here and paste it. Okay, so now it's registering this particular provider. I did enter one more time. It is registering another provider. Now you could have done this from the portal as well. So if you actually go to the subscriptions, okay, and click on your subscription, and then go down here, and it should be somewhere like that right there. Resource provider, you can click on that one, and you can look for this provider and see if it's registered. So now we have already registered. It will show up either as registered or registering, right? So like this too. We just said, hey, go ahead and register. The status is registering. So as soon as their status is registered, like the others, we can start using them. Okay, so the next task is deploy an Azure Kubernetes service cluster. So let's just go back over here, and what we'll do, we'll look for the Kubernetes services, and just like anything else, we'll look for it. And what we'll do in this one, create a Kubernetes cluster is what we need. Let's bring this window in the middle. Now we're going to create a new resource group for this particular work that we're going to do. Here's the resource group, and we're going to name the cluster as per our lab. Okay, that's the cluster name. Cluster preset configuration, we are not going to change. Okay, we're just going to go with the default configuration right now. Region, whatever region is, then I'm going to go with that. I'm not changing anything. Node size, get the default node count is 1. So node size, for this one, this size is not available, so let's just go with maybe east US. Okay, east US, let's see. So okay, so now the default size is available. Okay, scale method is auto scale is what I'm gonna go with. Not changing anything by the default. Node size and node count is 1. And range is saying that it can have up to 5. I'm just not going to change anything in here either. Next, go to the node pools. Okay, in the node pools, specify the following settings. So enable virtual nodes. Do you need that? No, we don't need that. So actually make it a little small here. Okay, so the virtual nodes needs to be disabled. Enable virtual node, we are not enabling. So there is a default enable virtual machine scale set, okay, and that is enabled by default, okay, and that is required for availability zone. So we have done that, okay, which is good. uh, Go to the authentication. How do you authenticate? Now over here, authentication, we want a system assigned manage identity. That is the default. We're gonna go with that. We are not creating any service principal for this particular work. And RBAC, do you want RBAC? Yes, it's enabled by default. We want that. And REST, I'm gonna go with the default again. Let's go to networking, which is a very important tab. And this one, just leave with the default one as is, network configuration kubenet, okay. And if you read this just a little, kubenet networking plugin creates a new vnet for your cluster using the default values. You can also use Azure CNI networking plugin. It will allow clusters to use a new or existing vnet with customizable address. Application pods are connected directly to the VNet, which allows native integration with VNet features. For this one, we're going to go with the kubenet. We need a DNS prefix and the default one, which is globally unique. I'm seeing the green mark, so I'm not going to change it. We're going to go to the integration. On the integration tab, set the container monitoring to disable. So we do not need that. So disable this for now. And no policy, we're not allowing attaching any policy at this time. Just say review and create. Let's see what happens. So that should uh, deploy uh, this particular cluster. Now what they're saying, in production scenario you should want to enable monitoring. Monitoring is disabled in this case since it's not covered in this lab, okay. And unfortunately this deployment sometimes take a long time, and they're saying about 10 minutes. Here I have some validation that is failed. Let's see what's wrong. And this is saying internal server error, and I could not deploy this one. Let's look at the raw error. Sometimes when you have a free account, uh, you get errors because you just don't have enough resources to deploy some of the servers. So I'm just going to go back. What I'll drop this one to maybe 2 node pool and retry my deployment and see if that works. If that does not work, I'm going to change my machine CPU, stuff like that. Okay, but let's see what happens here. Okay, so now it's still running the validation, making sure that it can actually deploy. And this validation is really check for the configuration. It's checking the ARM template. Your deployment can still fail at the runtime. This time the validation still they picked up over here, and I still have the internal server error. So I'm going to go back to basics and let's see, let's get rid of this too. Uh, did we have, I'm going to go back over here. Availability zone none, so we are not using availability zones at all. So make this none and STUS accept the default. Kubernetes version default, the standard is to recommended. Let's just choose something that is which one is chosen. Usually the one that is chosen is highlighted. Let's just choose, where is it, the default one. I don't see any highlight, interestingly, so let's not do anything. Let's just get rid of this and try to deploy again. Now, Kubernetes, you may encounter a problem like this, especially if you're using a free account just like I'm using. So don't get frustrated, just deal with it. let's see what is provisioning resource for container. I'm still getting template deployment. Oh, one thing we gotta make sure that the registration that we have done, is it registered already? So I'm just gonna go back here, go to the resource provider, uh, providers, and okay, so actually the both of them are showing to be registered, so that is not the issue here. What else can be the issue? I will redo this one more time. Okay, create. Okay, come back over here. Resource group is this. Okay, resource group is this. Kubernetes cluster name. Still it's taking it just fine. East US. I don't need any zone. This is too good. DS2v2. I'm just gonna go with maybe okay, scale mode. Okay, auto scale 1 to 2. That's all I need. Again, go to node pool. Look at this. Okay. Okay, that looks good. Okay, over here, enable HTTP application routing. Where are we? We are under networking. Uh, they said don't worry about anything else. Go to integration. Container registry. Doing none. Monitoring is disabled. This is disabled. Tag we don't need. This is my final try. If it doesn't work, then I'm just gonna let it go for now. It says validation passed. Okay. I still don't believe that it will actually gonna be able to deploy, but looks like this time the deployment actually happening. Not sure why, because we didn't really have too much of a different configuration. So again, Kubernetes, when you actually gonna work in a real production environment, you may see lots of challenges, and especially with networking, with policies, I see lots of challenges in the real world. Okay, so be patient if you're deploying a Kubernetes cluster. You may encounter some problem. Just read the error, redeploy, and what I recommend, move away from a portal-based deployment. Uh, Adapt to ARM template or maybe um, Terraform for this kind of deployment. Now this one probably going to take about 10 minutes, so let's take a pause. Alright everyone, looks like this deployment is now complete, so we can go to the next task. Let's see where we are. So we have done that. So we can start with the third task, which is to deploy the pods into the Azure Kubernetes Service cluster. Now every time we deploy something, always go to the resource and just take a quick look at it, make sure everything looks good. So this is the Kubernetes service that we have deployed. Okay. Network type, we have used the kubenet. There's only one more pull. Status is successful and it's running. STUS location, and you can go through some other properties and stuff in here. In this task, what we'll do, we're going to go to the settings section and go to the node pools. Settings is right here, and let's go to the node pools. And in here, what we said that we're going to use a couple of nodes, node count 2. The lab used maybe 1. Let's see. Settings, verify that the cluster consists of a single node pool. So right now we use 2. In the lab, we could have used only 1 in our setting at the very beginning. We just used 2 in our setting. In the Azure portal, Azure Cloud Shell, by clicking the icon, next we want to do, we will like to go to the Cloud Shell. Cloud Shell is right here. I have already opened, so you will go to the Cloud Shell. I'm just going to reopen this one and reconnect. And what we need to do, we're going to work with Bash. So if you are in the PowerShell, just click on it, click on Bash and confirm to switch to the Bash CLI mode, and you will be in there. Okay. Once you're in there, what you're doing, you are storing your resource group name in this variable, then and your cluster name in this variable, and then you are getting the AKS get credential from this. Okay, so let's copy this one and paste this, hit enter and see what kind of credential we get. Okay, so what it did, this command, it said it marched this as the current context in home student kube config. Okay, now what we can do, we can run this command kubectl get node, so that will tell me how many nodes are available, things like that. So let's see what happens. Kubectl get nodes, and all we need to make sure that we have a couple nodes in here, and these nodes are in the ready state, which looks good. Now the next thing that we're going to do, we're going to create the deployment of nginx deployment, and we're going to use the nginx image. So copy that, and again come back over here, paste the command, hit enter, and it said, hey, this deployment created. Make sure to use lowercase letters when typing this name of the deployment, nginx deployment. So everything we just copied, so everything should be good. Now we're gonna run these commands. Now those are the nodes. In those nodes, uh, we created this deployment. So now it's time to check for the pods. So kubectl get pods. Okay, and this is my nginx deployment, and that is the pod which is running. From the Cloud Shell, run the following to identify the state of the deployments. If you can also run this and make sure that the deployment is ready. Okay. And the last thing that you want to do from the Cloud Shell and the following to make the pod available from the internet. So now, if you're use a Docker person, so you know how to expose your port to outside. So you're kind of doing the similar thing. You're now using the kubectl command to expose the deployment of this particular container which is running port x80, and you want to load balance that. So now it says service nginx deployment exposed, and finally we're going to figure out what is the public IP. So run this and let's see what we get. So what is happening, here is my load balancer IP. Okay, so the port 80 31101 TCP, that's how it's mapped, and it's kind of pending. So this IP is not there yet. So we're going to rerun this command until these external IP fields are fulfilled. So let's rerun. Now we got the nginx deployment. I got that IP address 2081.123.160. Okay, and let's just copy this, and if we come over here and paste that IP address and see what happens. There we go. So now this is running at really port 80, and I have this application up running just fine. So we're done after this. So finally, what we want to do, we want to scale this containerized workloads in the Azure Kubernetes Services cluster. So again, let's go back to the portal. So now what we will do, copy this again, this to the same thing, and then this time we are providing scale. How many replicas do we need? We need 2 replicas for the same nginx deployment. Okay, let's just come back over here, clear the screen, and this time paste this command. Again, everything is stored, your resource group and your cluster name. Now hit enter for the deployment, and it says, hey, your deployment is now scaled. Now this time if I run this command, I'm expecting to see 2 pods, exactly what I was expecting. So this pod was running for 3 minutes, and this pod right after the scaling, it just started 9 seconds back. Next, we will do from the cloud cell, run the following to scale the cluster by increasing the number of nodes to 2. Okay, so this one created the pods, and this is going to scale the nodes to 2. Okay, so now I have 2 pods. So now let's copy this command and paste and hit enter. Okay, so this one I hit a problem. It says cannot scale cluster autoscaler enable not pull. Okay, so okay. So when we did our deployment, we did we didn't do a manual scale. We said autoscaler. So for the autoscaler, you cannot do that. All right, so let's just go back and see if I can change the scaling. Uh, Not sure if I can do that. Not pools, agent pool. Here we go. Auto scaling enabled. Let's see if I can disable that one or change that to manual. Okay, that is what we should have done. So let's just hit apply and see if we can change it back to auto scale. I mean, not auto scale to manual. Once we do this to manual, I'm just gonna run this command one more time. Get pods. I still have 2 pods. Now, let's just run this command, and this time, this one should wait, but this is still not allowed because another operation is actually in progress. So the thing that we have done, this enable thing, it's not done yet. So if I go over here, the scaling node pool is not finished. So once this is done, we'll be able to run this command. So just here now it's all good. So now let's try this command one more time, and this time this command should work. Okay, so now it's running, and let me zoom this back out. So what happened in a previous command, you could choose manual scaling or auto scaling during the Kubernetes deployment, and we select the auto scale by default when we deployed. In this lab, they have used the manual. So before we did anything, before running this particular command, we went back to the manual, and then we are using this AZK scale, and we are actually providing how many clusters do I need, and we are saying 2 is the number, node count 2. As once this is done, you will see that there will be 2 different nodes that will be running inside our pods. All right, which one are we doing? We're doing here. So then as soon as this is done, we're gonna run this nodes, and again this command could take up to 3 minutes, so let's just pause for us to save some video time. All right, the command ran successfully, and you can look at the output over here. But the point is, if you run this command right now, get nodes, hopefully you'll see 2 of them. And let's see what we get. And there we go. They are both up and running. And the first AKS pool, it was running for 23 minutes, and the next one, it just got created about 81 seconds back, or a minute back or so. We can also look at now this replicas 10, and for this deployment, now scaling really more, really hard. You can scale 10 replicas. Okay, now let's see how many pods we get now. Get pods. Oh my God, look at that. So that's how quickly you can scale. This is unbelievable, right? So this one is running for 10 minutes, the other one running for 10 minutes. But the rest of them, it just got created so fast. Some of them are there still in creating stage. So let's rerun this one more time, and all of them are now in running mode. That is just unbelievable. Um, so the next thing that we're gonna from the cloud server, run the following to review the pod distribution across the cluster nodes. So copy that one and paste. And if you do this is going to give you the distribution, which is with what? Okay, these are all the agent pools. Okay, this is the 0, 0, 0. So those, some of these, they're attached to the VM skill set 0. And there's another one, VMSS2. Some of the others are associated with that particular agent pool. So we have done that, and finally, all we need to do is delete the deployment, copy that one, and come over here, paste, and now this is going to delete our deployment. It says deployment deleted. So if I run this get pod thing, you see it's now probably getting deleted. If I run it a couple more times, now it's only 2, and if I run it another time, by the time everything is gone. Okay. So what? So that's really was the end of the lab. So we haven't really explained about a lot about the Kubernetes pods and nodes. So do a little bit of research on that. But we did complete our lab. We had a little bit of hiccup at the beginning at deployment time, but once we had a successful deployment of the Kubernetes cluster, we were able to complete the lab just fine. And the last command, this is similar to a PowerShell command where we delete the resource group and all the resources. That is what we're going to do. Hit enter, and it's going to get rid of all the content that we have created in this lab, and it will save us some money for the resources we will not be using. Thank you for watching. Have a great day.